So I'm not entirely sure why this is my Swiss cheese model, but I think there's been an awful lot of technical data, and sometimes, and I'm a bit like Jake, I like things nice and simple. I like to be able to understand it, and I actually also want to be able to tell you what's different this time, because that's actually the question, you know, why is it safe to fly now in sort of August 2013? Because it was safe to fly in May, 2012. What's the difference? So the Swiss cheese model will hopefully help us do that. If you go back to what happened in 2012, we had one new barrier in effect, and that barrier was to monitor the shafts that were part of a batch number, so 10 parts around the world, at an increased frequency. Download hums at an increased frequency for a particular set of batch numbers. And on October 22nd, we had a ditching where there was no affected part number. And that was why there was a difference. So there was no deviation from what was required. It was a different, it was the lack of understanding of the problem that led to the second issue, not the fact that anybody was doing anything wrong. So there was one barrier added in May as a result of the ditching in May, and that was the increased monitoring. And increased monitoring is not the best barrier. It's a good barrier, but it's not the best. And it's also too far down the line in terms of, a bow tie model, because something has actually happened at that point, and therefore you're mitigating risk. So from a risk perspective, it's the best thing to do is stop it happening in the first place. So if you look at this, so in the event of a gearbox shaft rupture, we lost drive to the oil pumps, it's land immediately, boom. So that's kind of where we are. So when you look at the barriers, the first barrier that we've got now is a maintenance barrier, and Tim explained that. So that's somebody doing an intervention, cleaning the inside of the shaft, and removing any residue or paste. That prevents the crack. So that stops a crack forming in the first place. Good, solid barrier. Stop it forming, you don't have to worry about the other things. That's done every 400 hours or every 2 years, depending on flight hours, or every 2 years, whatever comes first. And maybe done more frequently, depending on how each operator runs their maintenance programs. But the minimum standard will prevent a crack forming. Good barrier. So we want to prevent it forming again. So in the event that, we don't get it right first time, we all know the Swiss cheese model, that's why we're using it. Multiple barriers are better than one barrier. We need to prevent it at a second layer. And that's this replacement of the oil jet. So that improved lubrication, that engineering modification. So that's a change in design of a part and a retrofit part. So we've got a maintenance barrier, then an engineering barrier. So that barrier will then lubricate the internals, stop the residue forming, improve lubrication, stop the crack preventing. So that's 2 prevention barriers. Great. We're really trustworthy people, so we want additional monitoring. So in the event that the first 2 fail, which is almost entirely unlikely, we need early crack detection, and that's what Tim talked about in terms of the non-destructive inspection, the ultrasonics. And that will detect that very, very small 2 to 5 millimeter crack. Much more realistic and better for everybody to detect a crack if it's formed, not likely, but if it's formed on the ground. You don't want to find it in the air. If you find it on the ground, we don't return to service. That aircraft, just because there's another 20 hours, doesn't mean this thing's going to take off. And so it will be removed from service immediately at that point. So there's no lots and lots, we've got another barrier, so let's not worry about it. Let's do an operational risk assessment and keep going. No, it's grounded and impounded at that point, and it will be resolved and fixed. And the final barrier, of course, is the in-flight monitoring. Now, I think, so the in-flight monitoring is a really interesting thing, because in November we had a safety rep meeting, and a safety rep who actually I think is in this room stood up and said, wouldn't it be nice if we could have in-flight monitoring in the 225? And Eurocopter, I think, if I remember rightly, said that's not possible because it only happens in Airbus 380s, since it's a new It's a very new feature and everything else. So I'm not going to suggest for 1 minute that this is a result of a safety rep, challenging Eurocopter. But as a result of engagement, we've got in-flight monitoring of this vibration sensor. And I think it's really, really important that that's been put in. So it gives us that additional barrier. That benefit of engagement, that benefit of challenge, and that benefit of working in this way has helped us have 4 very strong barriers. So the last barrier is monitoring, but it's an entirely different monitoring solution from we had in May 2012. So this is what's different. 4 barriers, not just 1. And the 4th barrier has been increased, it's made more robust, and it's much more solid. So that's why we have confidence that all these 4 barriers working together are as good, at least as good, as a new shaft. And that's a really, really important thing for us. So we have to have these things working in that way. The reason we do SWISS-Gs is because we all understand it in our world. So we can give you the 6-page technical briefing, and you can go back and you can read that. But actually, I'm a simple instrument tech. I understand this. And that's my background. So this is much easier for me. So if you look at that, to prevention, to detection. Stop it happening in the first place. You don't have to worry about detecting it. If for whatever reason barriers fail, then we detect it early. If we miss that detection and we have 2 opportunities, we detect it in flight and land safely. So there's no requirement to ditch. It's fundamentally important that that's kind of the basis on which we're making the decision. Multiple barriers, multiple layers of assurance.